electricity. In this nugget, we'll be addressing electricity. We'll start off with a few simple principles about electricity, which is really mostly a description of various terms that you've probably heard relating to electricity. And then we'll also talk about various kinds of power supplies and how to make a decision in terms of which power supply to choose. We'll address surge suppressors closely related to surge protectors, and for our purposes, they'll be anonymous. We'll talk about the advantages of those as well as UPS systems. And then we'll also take a look at laptop power and special considerations to take into account when trying to troubleshoot laptops. I remember my first encounter with electricity. I must have been a grade schooler or something like that, and I knew what electricity was, and I knew you're not supposed to, stick paper clips inside of electrical outlets and things like that. My parents taught me well, but apparently not well enough. We used to have this old camper, and we would go camping periodically, and I remember it had one of those places where you could sleep up above the cab over the top of the pickup truck. And as I was looking up in that section one day, I looked up and I saw that there was no light bulb in a light bulb socket right up in that section of the camper. I thought, well, that's interesting. I wonder what would happen if I turned the power on to this switch. So I flipped it on, and I said, and then if I stuck my finger in that light bulb socket. Yes, I am a genius. I did just that. I stuck my finger in that light bulb socket and got quite a jolt. Now, I was just a kid, and that was the first time I'd ever been shocked. I'm afraid I've been shocked many times since then. And it wasn't enough power to actually do any damage, but man, I sure learned a lesson. I never stuck my finger in that electrical socket again. All right, then, so having learned then about electricity through my traumatic childhood experience, I'm going to go ahead and pass on my sage wisdom to you so that we can all know more about the principles of electricity, and we're really just going to go over some definitions here. Now, you may already be aware of some of these things. Maybe you were an electrician's apprentice, or you're just kind of handy with electricity, or maybe you were an electrical engineer. I don't know. But I know that for most people, and when they look at these terms, they know they're all electrical terms, but we don't really know exactly what they mean. We just know that if we see something that says, 5,000 volts and a big old lightning bolt symbol next to it, whatever that is, you just don't touch it. Okay, that's all we know to do. But let's go ahead and first of all start off with the discussion of what amps are. And by the way, some of these things really have an interrelationship between them. For example, you can't know anything about watts until you know something about amps and volts. So when we talk about amps, what is that really? That's really the measure of the volume of electricity that you're getting. It's the volume of electrons that are flowing through the system. Sometimes you'll also hear amps just called current as well. And then when it comes to the volts, I'm going to have a picture here in a little while that'll demonstrate this a little bit better for you, but it's really a measure of the electrical difference in a system, also known as really the potential difference between the electrical charges on one side and the other side of an electrical system. And just to make that a little bit clear for you for the time being, one side is usually positive and the other side is negative, okay, just like on a battery. The reason why you know the voltage on a battery is probably because it's listed right on there. It might say, a 3-volt battery or something like that. But that's because there's a difference between the negative and the positive side of the terminals on that battery, and that's where we get the volts. Again, I have a diagram shortly that'll show that to us. Let's also take a look at what watts are then. Now, watts is nothing by itself. It's kind of a dead term unless you know something about the amps and the volts. So if I have, say, 5 amps, that I'm using in an electrical system, and my voltage here is, let's say, 120 in the United States. By the way, this is 5A and 5V for the abbreviations there. In the United States, we have electrical systems for household current that's either 110, 115, or 120 usually. Although if you have high electrical systems such as an electric dryer or something like that, you might have 220 volts instead. But normally, you're going to be 120. Now, to get to the watts, you multiply the volts times the amps, and what would that be? So that would be 600 watts. That would be what we'd have, and we know that because we multiply amps times the volts to arrive at this. And then that's what you'll buy when you go to buy a power supply, for example, for your computer. You look for 500 watts, 600 watts, 700, 750 watts. A lot of them are getting pretty powerful nowadays. And then we also have two different kinds of current that we have here as well, alternating current and direct current. So then let's go ahead and address what something like alternating current would be, which we normally receive in our residences. The reason why we use alternating current to be received from a power plant is because it's very efficient in order to be able to transmit that alternating current. And what happens here is you'll have a power plant here of some kind, and it's sending electricity across cables, and then it makes its way eventually through a breaker box and other things, transformers along the way and all that, but then to a breaker box on your house, and then to eventually, usually an outlet here. Okay, so you got an outlet here, and I didn't draw the ground plug, the ground part of that, but you get the idea. Now, the alternating current here really vacillates or oscillates between positive and negative voltages. And in the United States, they oscillate 60 times a second, or in other words, it's a 60 hertz kind of a system. So it goes across the system plus and minus, 110, 120 volts into your home. And to further illustrate that, you'll have this oscillating up and down. So here at the top would be 110 or 120 volts, and that would be plus, and then at the bottom of this would be a minus 110 volts. Just the nature of this kind of electricity makes it much more efficient for the power company to drive that electricity and push it out to your household. But the problem with this alternating current kind of power is that it's okay for certain kinds of things. It's okay to run your garbage disposal, or to turn on your stove if you have an electric stove, or to run your hair dryer. Not that I would know much about hair dryers or anything, but that's okay for that kind of brute force power. For more sensitive electrical components, such as, of course, your computer or your laptop or other devices like this, it needs to be converted to direct current. Direct current is much cleaner power, and it works much better with very low electrical devices, low power electrical devices. And this is converted from alternating current to direct current by using a rectifier and a transformer. The rectifier is what actually does the transformation between alternating current and direct current, and then the transformer will transform it from a higher voltage down to a lower voltage. So for example, we wouldn't want all 120 volts going to our 3.3 volt processor now, would we? No, we want the transformer to be able to back that down to what's more than likely 3.3 volts. So now let's go ahead and talk a little bit more about voltage, and this is going to hopefully help us to understand that a little bit more. Let's say we have a body of water right here, and then we have a pipe here that pumps the water through this pump out of a spigot, hits a water wheel, and then it falls back into the body of water, and it comes back to a state of rest. Well, that's kind of really what happens with voltage as well. Here we have the low point of it. Then as we pump the water up through this pump here and out of this spigot, that's where it gets its highest point of pressure, its highest amount of energy, if you will. And then it can do something with that electricity. Here it can spin this water wheel. I know that looks kind of like a ceiling fan, but just work with me here, people. That's a water wheel where it will then be able to perform other work. So when we have the difference between its low point at rest and its high point where it's doing its highest degree of energy up here at the top, then that's where we have kind of a measure of voltage. And the voltage is the difference between its at-rest state and its high point. And with electrical circuits, it all goes in a big circle like this. Starts here, goes up through the pump, goes through here and does its job, and then returns to a state of rest. And we kind of see that cycle in the voltage here if we go back to this illustration earlier where we had a power plant, electrical cables to your house. Really, there's two cables there. And in fact, if you were to go out to your electrical panel and open up the electrical panel and unscrew the faceplate for that electrical panel, and don't do that, by the way, because I don't want you to shock yourself. So don't do that just because I said so. If you do it, it's your own fault. But anyway, you'll see that there are two cables that come in from the street. One of those is hot. Okay, and one of those is neutral. Just the same thing that you'll have on your electrical outlet. One of these blades, and that's usually the wider one on newer homes, they're different in size. The wider blade is going to be neutral, and the narrower blade is going to be hot. Well, what happens is the electricity goes through here and then returns on the neutral. That's the same kind of thing that we're seeing here. We see the electricity going through a whole cycle of electricity here, a circuit. So then in similar fashion, in our actual appliances and household goods that we need electricity for, we also have a high point and a low point. Now, you might have always thought in the past that the high point was associated with the positive symbol on maybe a battery or something, and the low point was always associated with the negative. I think that's just kind of a human perception, and it also used to be the actual, what we thought was the scientific accuracy in the past, but we found out later on that in reality, the high point is at the negative and the low point is up at the positive. But in any case, what we have here is electrical power going out from our power supply. And I just draw a battery in there for illustration's sake, and it goes out to whatever it is that we're trying to power. In this case, I put in a light bulb, and by the way, I hope you appreciate this, but this is probably the best artwork that I've ever had in any of my many CBT nuggets that I've done. At least it's pretty good for me. I'll give myself a C plus on this one, okay? How about that? So anyway, we have the voltage that goes out through here, or rather the electricity that goes out through here at the high point, and then once it uses the electricity in this light bulb, it's going to have some cast off. It's going to be able to actually power the bulb there, the incandescent bulb, but the cast off is also going to be some heat. It can't really use everything that it's using. In reality, just so FYI, for incandescent bulbs, they only have an effective use of about 10% of the electricity that they actually burn. That's why they're not as efficient as some of their energy sources. So in any case, then we have the return path here, and the difference between the high and the low would result in whatever the voltage was that was necessary for that particular device. Now that we know a little bit more about power, let's go ahead and address the power supplies. Now this certainly is an A+ subjective that you'll need to know something about. First of all, you need to know the proper sizing, and this is really in relation to a couple of different things. One of those will be form factor. Okay, this size will have to fit into a specific form, if I can spell factor here, there we go. Form factor. So if you have an ATX case, then of course you're going to put an ATX power supply inside of that case. If you have a BTX case, then you're going to want to put a BTX power supply inside of that case. Generally speaking, you want to usually put in the largest power supply that either you can afford or that you think you might even potentially need. A price per pound, power supplies are relatively inexpensive. You can get, usually for maybe $100, power supplies that are 600 watts or more. And inevitably, people add more onto their computers than they think they were going to originally. They might have put in an extra hard drive because they decide they need more storage space. They might put in an extra CD burner so that they can burn 2 CDs at once. CDs are definitely one of those devices that use a little bit more power, and so are hard drives. So as you add different things onto your system or to a customer's system, you might find out that they don't really have enough power. And generally speaking, for sizing in terms of the power of it, the watts, you don't ever want to use more than 60% of the available power. So if I have something like, let's just make it a 400 watt power supply, then I don't want to use any more than 60% of that. So let's see if I get out my handy little calculator here, because I can't think on the fly very well right now, but let's go 400 and then times 0.6. That would be 240 watts would be the maximum that we would want to be able to use. Now, why is that? Why can't I just tweak it all the way up to 390 watts or close to 400? Theoretically, certainly it could, but there are a couple of reasons for that. Number one, if you have to push the power supply that hard, you're going to shorten the life of that power supply, and also you're going to generate quite a lot of heat, because you see, power supplies, one of the things that they have to do in the transformation of the power is that since they're backing down the voltage in many cases there, that process has a cast off of generating some heat. And if you cause that power supply to work pretty close to 90 or 100%, then it's going to cast off an awful lot of heat, and it might not be good for the system. And just in an overall sense, and as a matter of good practice, you're probably going to get better reliability out of the power supply if you don't push it past 60%. And another reason why you wouldn't want to just go to the maximum of whatever the power supply rating is because when you first turn on the computer, you're going to have something called inrush power, where let's say you got 4 hard drives and 2 CD burners and all the other electrical components on there. Well, what's going to happen is when the power first turns on, it requires a spike in electrical activity and more power than they will normally use during normal operations probably while they spin up. And in fact, for some servers, they're designed in such a way that each drive spins up sequentially so that you don't get a huge amount of inrush power to get a large drain on the electrical requirements there. But if you're pushing this pretty close to 400 or so, when you combine that with the inrush power, there might be a chance that the power supply will just plain shut down because it thinks that it's being overloaded, and indeed it might be during the inrush power phase. Now this next thing is not really an A+ exam objective, but I do recommend that you get the best quality power supply that you can get. I mean, nothing happens unless you've got good power to your system. Along with the quality there, how do you know what a good one is and what a bad one is? I mean, you got Billy Joe Jim Bob's power supply and Peggy May's power supply down at the local electronics store. Who knows which one's really better? Well, probably the Cadillac of power supplies is what you can get from PCPowerandCooling.com. Those are very expensive, however, and even I can't afford them, so I usually get some different ones. But those are the Cadillac ones if you really want to go with the absolute best ones. Besides that, if you're holding two power supplies in the electronic supply store, and you got, maybe they're both 500 watts, how do you know which one's better? A general rule of thumb, and this isn't carved in stone, but generally, whichever one heavier is the best one. Why? Well, not because they put rocks in there or something, but because the better transformers are usually heavier. So if it's heavier, it's probably got better transformers. And just for your reference, I've gone here to PCPowerandCooling.com's website. Now, I don't get anything from them. They don't know who I am, so I have no real motive for recommending them other than that they're just commonly considered the best ones. Let's go ahead and just see how much some of these are. Here's the Silencer 750. Well, that's not as bad as I thought it used to be. It seems like they used to be higher. I might actually be able to buy one of these now, so that's not so bad at all. But you can also get lesser quality ones for quite a bargain. In fact, I just picked up a 500-watt power supply that by the time I turned in the rebates, actually it turns out to be free. All I had to pay for, really, was the sales tax on the item. PC Power and Cooling is going to make a much better power supply, and that's one of the other things that I like about PC Power and Cooling is that their power supplies do not have a whole lot of noise. I have bought some bargain basement power supplies before that I don't know if it was the fan design or whatever it was, but man, they were loud and very annoying, so that after a while I couldn't even get used to it. My brain wouldn't even just adjust. It just drove me nuts. I finally had to take that power supply out and buy a whole new one that was better with that. Also, when it comes to power supplies, if you ever suspect that you're having problems with it, you can use your digital multimeter to test. That's digital multimeter right there. That's the abbreviation for it. And in order to test it, you'll use the probes. You'll find the ground, and you'll find the hot connection. You'll take the black probe on your digital multimeter and you'll put it on the ground point, and then you'll put the red probe on the hot point, and then you'll be able to test what kind of voltage is coming through that particular connector. So for example, here I have a Molex connector, and we have a 12 volt, that's the yellow cable here, and you can see where it comes up through to this side, and then the red one that comes up to this side is a 5 volt. I wanted to test the 12 volt power on this Molex connector, so with the power switched on, I put the red probe into that particular section to test the 12 volt. Now, these two middle cables here, the black and the black, those are both ground. Why didn't I take this probe and put it into the black there instead, into that probe right there? The reason is, if these two accidentally touch while I'm testing this, then I could have a serious electrical problem. It could short out, it could melt these, it could cause an arc, it could do lots of different things that would really rival the time I stuck my finger in the light bulb socket. So I usually just go to some other nearby ground that's not where I wouldn't have the risk of accidentally touching these two together while I was testing them. Now, in all fairness, I probably don't have to be that paranoid because they have these, these little things on the side, these rings on the side of them that kind of prevent them from bumping into each other. But if I happen to hit something at just the right angle, it could still be a hazard. And then on my digital multimeter, here's the result from when I put the probes in there, and we see that it's 12.17 volts. Now, you might be looking at that and saying, hey, how come it's not exactly 12 volts? Well, it rarely ever is, and it doesn't have to be exactly the voltage that you're looking for there. What you need to do as a rule of thumb is keep in mind that as long as it's within 10% of the voltage you're looking for, you're within acceptable parameters. Now then, if you do run into a problem with your power supply and it's not giving you acceptable voltage readings, then you want to just replace it, because remember, your power supply is something that we call a FRU, or a field replaceable unit. Now, this is not something that you want to take the cover off, much like we talked about monitors recently. You don't want to take the cover off a monitor and work on it inside of it because it's an electrical hazard. Much more so is the case with a power supply because it has capacitors in there that store an amazing amount of electricity even when it's not plugged in, and you could seriously shock yourself with the power supply. So don't ever try to service your own power supplies. Instead, just get a replacement. Now let's also talk about surge suppressors, or they're also considered surge protectors. On the A plus exam objectives, they call them surge protectors. We're going to consider them synonymous for A plus, but there is actually a difference between the two, which I'll talk about in a little while. Now, first of all, with a surge suppressor, what we want to make sure is that we don't have a sudden and unexpected high amount of voltage rush into the computer and potentially burn something out. So a surge suppressor and a surge protector will help to prevent that from happening. They're rated according to joules. That Joule is pronounced a joule, and common numbers you might have would be something like 1250 joules, and this is a measure of how good it's going to be in terms of protecting your system against an over voltage. And they use a variety of different suppression methods. The first one would be a metal oxide varistor. And if you reach about approximately 200 volts, then the metal oxide varistor will redirect the power to ground and prevent anything from going into your computer, any over voltage from going into your computer. That's probably the most primitive method for doing it. There are a couple of other ways that I prefer much better. One would be a circuit breaker, and the other one would be a fuse. The circuit breaker, of course, you don't have to replace anything. If you get over voltage, all you have to do is to press the button on the strip to reset the circuit breaker. Or if it's a fuse, then you can just replace the fuse. And they're inexpensive, but wouldn't you know it, you never have one when you need one. So you'd have to run down to the store and buy one. And of course, both of these methods, when they're tripped, when the circuit breaker is tripped, it just prevents the circuit of electricity from flowing to the device. And a fuse also prevents electricity from flowing to the device because the the filament inside of that fuse, or the metal component inside of that fuse, heats up and it breaks in half. And that's what causes that fuse to stop the circuit when it breaks. Now, with the surge suppressor, you don't have what we call sag protection. Now, let me just discuss that a little bit. When we talked a little bit earlier about alternating current, it oscillates up and down, up and down, up and down. Whereas we get to direct current, we have pretty much a straight line of power if we were to display this graphically speaking. However, even with direct current, there's still little, blips of inconsistency in the power. And so the power supply itself does have some capabilities because of its capacitors to be able to handle those little blips in power, and it can still work okay. But if you have a dramatic dip in power, then you don't have anything in the power supply that's really going to be able to help you with that for a dramatic dip, or if you're having a brownout, for example, or something like that. A surge suppressor also does not have any kind of sag protection. So in this case, if you had some kind of sag in your power that took place, what's likely to happen is your system will either just reboot, and you could potentially lose some data. And actually, that's the most likely thing to happen. It's going to spontaneously reboot with that sag. Now, technically, there is a difference, as I mentioned before, between a surge protector and a surge suppressor. You see, a surge suppressor also does help a little bit to clean up the power as it's going to your PC, whereas a surge protector is really only designed for suppression. That's all it really does. So if you get an overvoltage, it'll help you there, but it doesn't do anything to clean up the power. So for that reason, a surge suppressor is a little bit better than a surge protector. Now, be careful of power strips. Some people might just go down to the local hardware store and get a power strip thinking that they're getting surge suppression. They might not be. They might just be getting 6 outlets on a strip, and that's it. So make sure you avoid power strips and get a surge protector, or even better, a surge suppressor. All right, now I'm going to go ahead and cover uninterruptible power supplies. Now, this is not technically necessary for the A+ exam objectives. In the old exam, I think it was the 2003 A+ exam objectives, they included UPSs. Now in the current exam, they've taken them off of that exam objectives. I think that was probably a mistake in my humble opinion, because UPSs can be very useful and very important, and they supply all of the same features of a surge suppressor and more. Our basic idea for a UPS is that if the power totally goes out, you're not just having a sag, I mean, you have no power whatsoever, and the lights have gone out and everything. Well, the UPS can continue to supply power via a battery for a period of time, at least giving you enough time to close your documents and save them and shut down the computer manually. In fact, they can even include certain software that will do this for you automatically, but I'll come to that shortly. There's a couple of different types of UPSs. There's a standby power supply, also known as an offline power supply. And with this one, what happens here is The UPS is really just kind of a conduit for electricity. It goes from your wall outlet to the UPS and then out to your PC. And it's really not working much differently than a power strip or a surge suppressor, excuse me, would do at that point. However, if the power does go out, then what happens is there's about a 10 millisecond lag between the time that the power goes out and an SPS or offline power UPS is able to come online and start supplying battery power. Now, most power supplies inside of your computers are capable, because of the capacitors in there, of bridging that 10 millisecond gap, but for me personally, I'm still not comfortable with it. I'd rather have more immediate power, even though 10 milliseconds is a really short period of time. The other kind, which is going to be much better, would be a line interactive. And the way this one works is that let's say we have our utility power here, which is another way of saying, utility power from your power company. And here's our wall outlets again. And we're plugged into these wall outlets to our UPS. And I'll just draw a big battery here. No, your UPS is not a car battery. Do not hook up a car battery to your computer. I'm just kidding. But this will just be representative of the battery from our UPS. We plug into it. And then what we do is we also have our PC down here, our computer. Now, the computer is plugged into an outlet on this uninterruptible power supply. The power that's coming through here is actually charging the battery constantly to keep it in a fully charged state, and the PC is actually drawing its power not off of our utility power, but off of the battery power from this uninterruptible power supply. So then what happens is if our power goes out to the PC's perspective, there's no gap in the time there. There's no catch-up time between the time the power goes out and the time it starts receiving power from the battery, because it was already receiving power from the battery at that time. So I like the line interactive methods better because there's not a transitional problem there. Now, most UPSs these days are not very expensive, relatively speaking, $100, $150 for a really good one, and they're almost all line interactive these days. Also, we get additional features with the UPS. We get automatic voltage regulation. It's able to handle much better than a surge suppressor, various little spikes and dirty power and sags and all those kinds of things. Much better in terms of handling sags or brownouts, surges, spikes, and it does a really good job of cleaning up the power to the PC, which is going to be easier on your power supply. Help to ensure a longer life for all of your system components. Now, with the UPS, we connect to the UPS also. It's not just the power that's hooked up to the PC. There's also another thing that'll be hooked up to the PC, and that can either be a serial, so I'll just write in here serial, even though I got it written down at the bottom, or a USB connection. The most common one these days is going to be a USB connection. Now, why is that? Because when the power does go out, the UPS at that point sends a signal to the serial or UPS port, which coordinates with software that you have installed. You know, APC is a very common manufacturer of UPSs, and they have something called PowerShoot software, which you can configure so that when it does get a power outage, you tell that software what you want it to do. And the software knows that it's supposed to start taking action because it received a signal through that serial or USB cable. And the actions that it might take would be, after it gets to a certain percentage of battery drain, to go ahead and do a graceful shutdown, or it can even be configured, depending on the software, to save your documents and then close any open applications that you have. So you can see it's very graceful in the way that it handles all of these things. I think that perhaps the A+ folks at CompTIA thought that UPSs were more for servers, but they're really not anymore. And I've got a couple in my house for all of my different systems, and they really seem to work fine. When our neighborhood was new and the power was going off a lot because of construction, these UPSs really saved my data. Now then, later on, we're going to have a section dedicated only to laptops because they have some uniqueness to them. However, in terms of the power of laptops and the management of all of that, it really seems to fit better with this electricity section, so I'm going to go ahead and cover that part of it now. We have AC power adapters with our laptops. And I know you've seen these before. You have the two blades on the end of a plug right here. And then, then you have a cord, and then you have a big, ginormous, heavy brick that you plug into your laptop using another cord, which has a small round connector on the end of it. And it's hollow in the middle, and it plugs into a pin on your laptop. Well, this is really a nuisance. And by the way, this is one of my peeves as well. You see, a lot of these things right here combine the transformer and the inverter into this brick. That's why they're so big and heavy, and that's why they get warm after you've had them plugged in for a while. Well, that whole thing in a miniaturized kind of a version used to be integrated into a lot of the laptops, like the older Toshibas. However, once they did that, then their laptops became heavier, and so the specs didn't look as good for marketing purposes. I mean, after all, what would you rather have, a heavier laptop or a lighter laptop? Most people want a lighter one. Because of that, they had to take that whole thing out of the laptops and put them directly onto the power cord. Now we got to haul these big old giant bricks around the country with us. So anyway, that's what we've got. Now, in terms of the switching, we have something called auto switch and fixed input, and this relates to our 120 or 200, oops, if I can write here, 120 volt or 240 volt power. Of course, in the United States, we have 120 volt power outlets. In other countries, there's usually 240 volt outlets, such as in Europe. And so you have to know where you're going and what you're plugging into. With a fixed input, this can go a couple of different ways. There might be a switch, and this applies to desktops as well. There might be a switch here where you can take your thumbnail and slide it this way. And if you slide it that way, it might be 240. If you slide it this way, the other direction, it might be 120 volt. And you just look on it, it'll be real self-evident when you look at that switch. That would be a manual switch. There might also be a fixed input in which it's only 120 and it can't be switched, or only 240 and it can be switched. And the best one of all would be what we normally have for our laptops, and that is our auto switched ones. So for example, if you look on the power brick itself, it'll probably say something like input 120 volts slash 2.4 volt, 2.4 amps or something like that. And then underneath that, it might say 240 volts slash 1.3 amps, something of this nature. And what that means then is if it has both of those on there and there's no manual switch they have to slide one way or the other, then it's going to be an auto switching. As soon as you plug it into the wall outlet, it can automatically detect how many volts and amps are on that wall outlet and adjust accordingly. Because you wouldn't, of course, want to plug in your 110 volt designed laptop computer into a 240 volt outlet without having the auto switching take place, because you might burn out your laptop. And then when it comes to verifying whether or not you have an AC or a DC connection, that can be pretty easy. In terms of verifying the AC power, just work with this side of things. One of the things you want to do is if you have a multimeter, you can just check the outlet to see if you're getting good power out of the outlet in the first place, or plug in something else, a lamp or something else, an alarm clock, to see if you're able to get any power out of that. Otherwise, what you could do is to check the LEDs. A lot of times on these little power bricks, there might be off in a corner here somewhere a little red or a blue or a green light that comes on just faintly, identifying that you do receive power from the wall. And if that's the case, but you're still not getting power to the laptop, which would be at the other end of this connection, then you know that everything's good up to this point, so it might be either this item's not plugged in all the way or some other problem with the laptop. Especially if they don't have one of those little lights and you have a spare one of these cords, spare one of these bricks and everything, especially if you're in a shop where you work with a lot of the same kinds of laptops, then you can just swap it out and see if you get any power then. Now, again, also in the absence of one of these lights on the brick itself, you can also look at the laptop itself. Almost always they're going to have something like an LED that either flashes or remains lit, or a little electrical symbol looks like a lightning bolt that flashes or remains lit, identifying that you are getting power from the wall outlet through this brick and on into your direct current. Now, if the LEDs aren't coming on, it doesn't look like the laptop's getting power, one thing you can also do is to just replace this with another one. Maybe you have another one in the shop from the same manufacturer and everything, especially if you work for a company where you use kind of standardized laptops, and you can see then if you're getting power to that laptop. And then also, like I always say, always check the physical whenever you're troubleshooting. Make sure that this is plugged all the way into the wall outlet. There's also, this usually also disconnects right here. I don't know why. I think a lot of the reason for it is because they want to make it more portable so you can take all of this apart and store it in a little more compact space. So make sure that when you plug it back in, you plug it back in all the way. Sometimes that's kind of a stiff connection there. And then sometimes this might also be a separate connection here as well. Usually not. Usually it's molded directly into the brick, but just keep aware of that. Also, be careful to look at this to see whether it's frayed or not. Maybe sometimes this can get bent out of shape or a little bit stressed, or maybe somebody dropped this brick while it was still attached to the laptop, and so they lost their good connection here, and you might have to just replace the whole thing if that's the case. And also make sure that this part is also plugged all the way into the laptop. And that's the kind of thing when I say plug things all the way in and make sure there's nothing loose there. That's what I mean when I say you're verifying the connections there. Now, going back up here to the DC item, in order to verify that, you can also use your multimeter. So what I want to do here then is to use my probes to check my power supply. So here I've taken the black probe and I put it on the outside of this connector, and then I've taken the red one and I put it on the tip. Now that's not always going to be the same. A lot of these are hollow inside, and you can take this tip and put it down inside of this connector, and then you test it that way. It just depends on what kind that you have. Regardless, once I've done that, and of course this is plugged into a wall outlet on the other end of this, then we see that we get to this multimeter here where we have our reading, and it's supposed to be an 18.6 volt reading, and so we're pretty close to right on target with this one. Now, in terms of performance for your laptop, there are a couple of things that take place here as well. So, for example, if you have a lot of peripherals attached to that laptop, even though, for example, USB devices are fairly low power, on the A+ exam objectives, they seem to think that if you have a lot of things attached to it, that could be a significant drain on the power, on the battery, for example, and so subsequently could affect your laptop performance. In my experience, I find it unusual for people to have a whole bunch of stuff dangling off of their laptop in terms of those kinds of peripherals. I do see that some people might put in a PC card, and that might be draining power even if it's not being used. For example, I might have a network card in my PC card slot, even though I'm not connected to my network. If my battery is continuing to power that PC card in that slot, then I'm wasting battery power. But a lot of them nowadays can automatically sense whether that card is being used and then just turn off power to that card if it's not being used. Another thing that would affect power would be something like an external hard drive. Some of those are powered only by USB power, and hard drives are kind of notorious on their own for draining power, so that would be one other thing that could affect your performance. But another thing that you can do is to use something called throttling. Now, this is not necessarily something that you do on your own. What this is, it's a laptop technology that works in conjunction with processors that are designed to follow a throttling procedure. What happens then is if you're not really using the processor much, maybe you're just typing a simple letter or something like that, well then it's going to throttle down the processor so that it's not using all of its available processing power, just enough to allow you to do your job. It's not like you're playing, some high-end computer game on there or something like that, or you're performing high-end calculations, scientific calculations, or running some kind of a test like that on your laptop. If you were doing something that required high processing power, then it would release those CPU cycles back to the system so that it could take advantage of the CPU. But once again, if it's not really doing that much in the first place, then it throttles down. Now, if you're working with your batteries in your laptop and you want to conserve battery power under certain conditions and the like, then what you can do is to go into your control panel, and then you can go to Performance and Maintenance on Windows XP. If you're in a previous version of Windows, go to the Classic View, and I can have the option to go to the Classic View here in XP, and it's going to look much like this in Windows 2000. And here you would then go to your power options. So going back to Category View for Windows XP, because I think a lot of you are going to be using that, then we can go to Performance and Maintenance, and then Power Options. And once we get here, then we can choose what kind of power scheme that we want to be able to have. And there's a number of different ones that are available, such as portable laptop, for example. And this will be much easier on the battery life. For example, it's going to send the system to system standby after only 20 minutes. This means that there's going to be very low power going to the system, just enough to charge the memory and the processor to a very basic level of functionality, very minimal power that's necessary there, just to kind of keep it alive. It's kind of like the battery is just administering CPR to that system long enough for it to be brought back to life when you open up the cover or turn it back on all the way. By contrast, System Hibernation, what that does is it's only available if you've gone to the Hibernate tab and selected this checkbox to enable hibernation. It has to have enough available disk space to be able to do that. It has to have the same amount of disk space as there is RAM in the system. I've got a gigabyte of RAM, so you can see how much space there it needs in order to be able to hibernate. And the reason why it needs that is because it takes the entire contents of RAM, dumps it to a file on the hard drive, and then totally turns off the power. Then when you turn on the power again, it reads all of that data out of that file on the hard drive, sends it back into memory, and you're back into the same situation that you were before you went into hibernate. All your applications will still be there, your documents will all still be in the exact same place that you left them, all the windows will be in the same location, and so forth. The only thing we don't see directly here is that if this were a laptop, there would be a plugged in and an on battery setting. So this would actually appear in two columns. If I was plugged in, I can turn off the monitor after 45 minutes, but on the battery setting, I might turn it off after only 5 minutes if I really want to save some power. And you can also turn off the hard disks after a certain period of time as well. That's kind of useful because the hard disks, like I said, do use a lot of power, and the hard disks also constantly spin, so they're constantly requiring power. But on a laptop, might want to cause those to spin down so that they don't require that much power until you need them again. And the system will know if you need more data off of that hard drive to read or write, and then it will spin the disks up for you again. And then on the Advanced tab, there's an item here. When I press the power button on my computer, and this one's for desktops, you can identify what to do, and these all explain themselves. And if there were a laptop here, there would also be an additional drop-down list that would say what to do when I close the lid on my computer. And for example, what I do on mine when I close the lid, I have it send it into hibernate. My wife has hers go into standby. So it just depends on what your preference is. The other advantage of standby as opposed to hibernate is that standby will resume back to full operation much more quickly than hibernate will, especially depending on how much RAM you have, because if you've got, let's say, 4 gigs of RAM, then it has to read up to 4 gigs of data from that hibernate file on the hard disk back into RAM, and that can take a little bit of time. In this nugget, we talked about electricity. We talked, first of all, about some basic principles. What's an amp? What's a watt? What's a volt? All of those kinds of things, as well as how electricity flows through a system. And we also talked about power supplies, how to select the right power supply, how to load a power supply so you can make sure that it's not overloaded. In other words, how to size that power supply. We also took a look at surge suppressors so that we could identify something that can help you in the event of an overvoltage. And we also took a look at UPS systems, which of course are not part of the A+ exam objectives anymore, but which are nevertheless important. And then we concluded with some issues about laptop power, how to troubleshoot if you're not appearing to get the kind of power that you need to your laptop. And also how to conserve battery power using the power options from within Windows. Well, I hope this has been informative for you, and I'd like to thank you for viewing.